Yeah, okay. Sorry for the interruption. Sorry. Some connect live connection problem. Only. Okay. So I hope everything will see my screen and my voice is audible. So now I continue to the session. Okay. So without delay, I can enter into the session. So today we can start with that GANs. So GAN is one of the generative AI's important model. How the GAN should be work and what is the procedure to implement the GAN model? These kind of things we will see in today's session. First of all, the GANs is represent to the generative adversarial network. That is the abbreviation of the GANs. And the GANs was short are an approach to generative the modeling using deep learning methods such as convolutional neural network. It is based on working from the CNN like architecture, that is a deep learning neural network. And they were introduced by Lan Goodfellow and his colleagues in 2014. In this particular GAN model, it is introduced by this kind of people, that is Lan Goodfellow and his colleagues. In 2014, this kind of model will be introduced. Okay. So now, okay. So then, how the GAN will be works means in the VAE model, it's based on the reconstructing the particular values, right? Reconstructing the particular values or image or data, whatever it is. But the GANs is based on the to analyzing the data, is original or fake, to analyzing the fake or real data based on the classification concept. Okay, so here this is called as a, for example, is four kind of options is there. The first one is an digit based image. Second one is a human's face image. Third one is an animal's structure image. Fourth one is a leaf disease image, right? I think it's the leaf exact thing. Yeah. There is four common examples for GANs model. Okay. Today we will see about this handwritten digit based project. We will discuss about GANs model. Okay. In upcoming session, we can learn about the human face generation. Okay. So our topic today, we have to take in the topic is in leaf disease detection, but some kind of issues we cannot take that. We can continue with that tomorrow. So today we will be entering into the GANs model. Okay. So sorry for that. Voice is not loud. Can you check it your volume? I think every side, like everyone hear my voice. Yeah. The GAN is the purpose of the GAN model is using for the particular data is in real or fake. That is our major motto for this GAN model. The VA is reconstructing the image. Okay. So, but in this particular GAN model, the particular image is in real image or fake image. That kind of identification purpose, the GAN model will be used. Okay. So then the GANs are generative models. They create the new data instances that resemble your training data. The GANs can create images that look like photograph of human's face, even though the face don't belong to any real person. And in day one, I have to tell one thing, so I forgot it. So now I remind that. So if everyone have a mobile phone or a laptop, right? So you can go with your go with Google or any kind of browser. You can search this one. This person does not exist. This kind of command you can search with your browser. You can get it some kind of images, humans images. In that particular human is not exist in a real world. Okay, it's fully working based on the working for the generative AI model, like AI model. Okay, in this particular, every people is not a real persons. It is a AI generated face images. Every time you can reload this page, you can get it the every random peoples. It is not about the age and gender related. It is commonly every peoples are there. So you can filter it that. If I have to female means only female people's images only generated. And if I have to male means the male people's images only generated. So you also try this one. It is an influential based on generative AI model thing. It's a full body option also you can get. So like this way. So random face, so whatever it is. So you can try this one. So in a day one, I have to set to this. I forgot this. Okay. So now we can continue with that. Same like us, the GAN model listen to generate the new image, and the final thing is the particular image is a real or fake. That is our final output. Okay. Oops. Yeah. Okay. So now we can continue. And the generative model is an unsupervised learning task in machine learning that involves automatically discovering and learning the regularities or pattern in input data in such a way that the model can be used to generate or output new example that is plausible could have been drawn from the original data set. So everything is they have some kind of original data for the training purpose. Then we can recheck that for the testing purpose. We can give us some kind of images for our prediction or our generation or identification for this kind of things. Okay. So generative like this GAN model also working like that. Okay, is GAN model only using for images only data set, maybe such as like stock market forecasting data set. No, it is only based on the image related. It is generating new image. The particular letters or characters or numbers, everything will be present in an image format. It's generating like take that input for training purpose is also we can use the images, and our testing or identification process also we can find out the image in that particular object. Sorry, in that object present in the image. Okay. So next one, the GANs or generative models. They okay, same thing is in the repeated, right? So they create a new data instance from the your training data, and also it's an create the image. It is photograph of human or whatever what kind of things we can create, but it is not a real. It look like a real, but it is not a real or exist a person. Okay, so the image is created like this. So image is generated by GAN created by NVIDIA. So NVIDIA model it will create this kind of human's face. So just now I said the one kind of thing that this person does not exist. That also NVIDIA's one of the website. The next one, the GANs are an exciting and rapidly changing the field and delivering on the promise of generative models in their ability to generate realistic example across a range of problem domains. Most notably in image-to-image translation tasks, such as translating photos of summer to winter, day to night, and generating photorealistic photos and object scenes and people that even humans cannot tell are fake. So generally, generative is also multiple applications are there. In day one, we will discuss. So we was discussed, right? That is one image to convert in another image. So the face exchanger and also object remover, background remover, everything will be happen into this particular image generative models. Okay, so it is also one of the basic thing in GANs. A generative adversarial network system comprises two deep neural networks, the generator network and also discriminator network. Okay, so here we can use the two kind of models. One is a generating purpose, another is a discriminating purpose. One model will be create the image, like create the data. Another one is to identify the data. So it is the real or fake. Okay, so it trains two neural networks to compete against each other to generate more authentic new data from a given training data set. A GAN is called adversarial because it trains two different networks and pits them against each other. One is the image generation, another is style transfer. So first one is the image generation is GANs can create the photorealistic image of non-existent landscapes, faces or objects by learning patterns from diverse training data. And style transformation, GANs can transform a photograph of a city into an artwork reminiscent of a famous painter's style, seamlessly blending artistic characteristics. So what is the both reveal the things means the image generation. The generator will be create an image based on the realistic people, but it is not a real people. But the style transfer will be apply the some kind of effects or the kind of designs and the model. Everything will be applied the particular data. Here we know the fake by rupees, fake cash, right? The fake cash also is mostly happens now. So the real cash or fake cash. The side is in between the real and fake cash. We have some similar difference based on the thickness of the paper and also some kind of designs and a particular the pin. So everything will be find some kind of difference between the real cash or also fake cash. So same like that, the particular discriminator will be identify the data it is real or fake. So it is the application of GAN. We can convert the monad like day to summer to winter, zebra to horse, and photo to drawing art, and horse to zebra. So whatever it is, we can convert monad to photo, photo to monad, and zebra to horse, horse to zebra, summer to winter, and winter to summer, on day to night. So this kind of way we can convert the image, a single image into the another image. Yeah, this is also one satellite image into the aerial view, and photosynthesis into the normal view. And what is that? Yeah, drawing a sketch art into the real image, day to night. This kind of way we can convert this one. So then with a human face recreation, that is another project. Today we can just learn what is basic GAN model work. Then we can move on to the human face recognition. Okay. So then super resolution also is there. So super resolution is GANs and enhance the resolution of low quality to satellite imagery, revealing the finer details for improved analysis and decision making. Data augmentation is the GAN generates synthetic medical images to augment training data set, aiding in the development of more robust and generalized diagnostics model. So the resolution enhanced and data augmentation, this everything will be we can do in that particular GAN model. Okay, we can starting from the MNIST digit, handwritten digit image generation. This is our today's image related project. Yeah, next one is history of GANs. So what is the history? That means starting still the GANs will be introduced from the what is that Goodfellow, Paul Goodfellow to introduce the particular GAN model. So starting with the 2004, it's having only basic GAN model, that is GAN framework proposed. Then it's converting into the CGAN, that is convolutional GAN. Next they it's move on to the deep convolutional GAN, and it's in every year it's updated versions are there. The Pix2 Pix and stack GAN, cycle GAN, and W GAN and Pro GAN, star GAN, deep fake, flow GAN, ESR GAN and style GAN, each GAN still is having SA GAN. So in 2020 is the latest update of the we have had 20-25 years still be running. It's having some kind of updates also there. So I'm not implement here. So next one, this is the best example for the evaluation of GAN. So in 2014, it still is happen here. In 2015 is update. 2016, 2017 is almost is there. Still, it does look like a real person. It is present in our real world. We can see look like that. The 3D image also we can generate in this particular GAN model. And next one is having the GAN model architecture involves two kind of submodels. One is a generative model, another one is a discriminator model. The generator model to generating a new example, the discriminator model to classifying the generator model as real or fake. Okay, it is a original image or the fake image. The discriminator will be identify that. Next one, the generative. Okay, the generative adversarial neural networks are based on a game theoretic scenario in which the generator network must be compete against an adversary. The generator network directly produces the samples. It is adversary. The discriminator network attempts to distinguish between the sample drawn from the training data and the sample drawn from the generator. So now I have the story-based examples for this particular GAN model. Okay. So we have two kind of players. One is an cop, like cop, and also another one is a thief. In this particular place, the thief is a generator, the cop is a discriminator. Why we said like that means the thief will be generate the fake, what is that? Fake cash rupees. Okay, fake rupees cash. That means whatever it is, fake cash will be, the generator will be create. The discriminator will be identify it is a real or fake. That is the in between the verses of these two different models. For the generator will be, yeah, that's why I think he is a generator, he is a discriminator. Then the generator will, generator's major motto is to create the original image, look like a original cash image, like a cash, but it is not a original, it is a fake cash, but they look like it's a real. That is the his major generator's major motto. So he need some kind of model. That means sample. So he takes some kind of real money for his working, for his creating fake monies. So this is a model sample for his fake money creation. Okay, so train here we can say like to our concept, it is a training data, it is a generating data. Okay, so the discriminator will be when the he submitting the rupees look like this, then only the discriminator will be allowed it is a real or fake. Okay, so based on the features, the discriminator will be analyzed it is a real image or fake image. So first he will try to show it into the empty blank paper. The discriminator said it is a fake because it is not having any kind of designs or any mentioned things is not there. Okay, so once again, the generator will be do that in another additional added values. That means it is getting this one, some kind of border designs. Here, this time also the discriminator said it is a fake one. Again, it is do with an added some another works. Again, it is, he said it's a fake one. Finally, it's a 100% accuracy about the real related to real money. This time, the discriminator will be approved. It is a real one. So we know about this, it is a fake one, but the discriminator is allow this is a real one because of the fake image is like the fake data is look like a real data. The every features, the every pointing, every labels and every parameters is a look like a real image, like real money. Then only the discriminator will be allowed. It is a real one. Okay. So now I will show you the one kind of example for this. So same like a yesterday format. I'm going with that paint. Okay. So now I can try to show you. So before that, I will explain this one. So first of all, we have two kind of submodels. One is a generator, another one is a discriminator, right? So then we first of all, we can give it to the one kind of data to the generator model. We have an additional training data set is here. So it is based on this training data set, the fake image will be generated. The discriminator will be identified with the both. So training set also is there, and fake is compared to the these two things to decide this is a real one or fake one. Okay. So generator will be create one kind of fake image to give it to the discriminator model. So the discriminator will compare with this particular training set. So they have some kind of things, right? So it is missing this one. So this is a real one or fake one. Finally, the discriminator will be decided to this image is a real or fake. Real is it's move on to the real, or fake is move on to the fake. This is the way the discriminator generator will be work. Okay. So here I also showing one thing. First, I have one of the for discrimination, huge data set will be required. It's not like a huge data. These have two data. Okay, one is a testing, like generating data. Another one is in real data. And only the discriminator will be comes to the one kind of understanding, like identification. Then how it is happen to discrimination is it find out the one kind of decision it is a real one or fake one. So real data also is need and training data is need. Yeah, of course, the training data is having a large dimension. Like okay, so here for example, what I take. Okay, so you're having some kind of same like I take the same concept into money. Okay, 1 rupees money. Just an example I can give it this for 10 rupees. So I can't write. So kindly wait. Just a minute. I have to connect this one to. Still, I have some kind of thing. Okay, so now I have a one kind of data, 10 rupees data. So I have to generate like this kind of no, money into my generator model. So here's a generator G model. So I have mentioned like a G is a generator model. Same like as the discriminator is having additional thing that is training data set. So training sets also there. Training data. Okay, sorry for that. It is not comfortable to write in here. So some kind of training data is there. So in this, every data is having some kind of original money is there. The original money model is there. So once the creating data like this, the fake money, the fake 10 rupees money will be it is a fake one. The fake one. It is passed into the both are passed into the discriminator model. Okay, discriminator model. The discriminator model is here. Just in D, I mentioned to the discriminator. So here it is comparing to the two different things. So fake one is also there, the real one is also there. So both are comparing with this particular discriminator. So if we had any similarities or any differentiations happen, the discriminator will be decide it is a fake one. So final output is having it is a real one or fake one. It is a real means is mentioned like a real or else it is a fake. So it is mentioned like this kind of concept. So in case the real one is having in particular place is having some kind of things. For example, I will represent into like this, same 10, but in the edge of these things, some kind of mold is there. Sorry, folding or any marker is there. So the both the these kind of markers is missing in this particular fake image. So automatically discriminator will be decided it is a fake one. So final output is a fake one. Or else the fake image is also there in a particular similarities between the real like training and a fake testing. I mean generating image. It is decided to the it is a real one. Okay, so based on the trainings data, the discriminator will be decided it is a real or fake. Okay, so then we are move on to the next one. So first it's generating the random vector for the generating model. The model will be, the generative will be create one kind of example fake one. The real example also that the both are combinedly move passed, pushed into the discriminator model. The discriminator model will be decide it is a real or fake. That is the binary classification. Or else, if for example, is in the real one means there is a no problem. If that the discriminator will be decided is a fake one means again it go on to the generated model. That is the reverse backward propagation. In last class, I have to say, right? So in case we cannot get a proper output means we have to go with an backward propagation. In this place, it's happened. The real one, the model, sorry, the image or data is in real one means there is a no problem. It is, in case it is decided to the fake one means it is move on to the, again is go to the backward propagation. Again is go to the generated model. The generated model will be add-ons to the additional features about the particular image. Again is come to the discriminator checking. Okay, so this is the way the GANs model will be working. Here is the example for the first is a real one, it is a fake one. Sorry, the blue line is a fake one, the red line is a real one. The first process, it is decided to the fake one. Again, let's go on to the next one. Again, is move on to the next step. This kind of fake one is move on to the next one. It is a generated model, generator image. It is in the real image. First, the generated image is decided to the fake one. It is move on to the backward propagation. Again, this comes to the additional thing like one more time. Here, it decided to the one step will move on. It's nearly a real one, but it is having missing some kind of features. Again, it's go on to the final step. Here, it is decided to the real one. Okay, it is similar to the real image, so it is a real one. The discriminator will be decided. The both are real one, like real image like that. Okay, we have to go through the flowchart again now. Okay. See, first we can create some kind of data, training data given to the particular model. Based on the data space, the generated model will be creating one kind of example, like sample data it's create. And also we having a real example, like the training data is called as a real example. That means a real data. So in this place, the both are combinedly entering to the discriminated model. The discriminated model will be analyzing the both one. So generated one and also real one. So comparing with it to both, the discriminator comes to the some kind of decision. So both are similar. It's decided to the it is a real one. Generated is a real generating image. Or else if you have any missing features is that it is decided to the generated example is a fake one. Okay. So real one means which comes to the output. The fake one means it's again going to the generated model to adding some kind of features. In this place, our motto is we have to create the fake one, but it is not decided to fake one. It is a real one. It looks like a real image. So these are the same like the green is in forward propagation and red is in back propagation. So first we can give the input randoms to the generative model. The generative model will based on the data space, it is generating kind of sample image. Okay, in generated model training data set along with your random input, is it to be used? Yeah, of course, yeah, exactly. Yeah, based on the random data space, the generative model is created one kind of fake model. Okay. So when the model will be comes to the discriminator place, the discriminator will be decide it is a real one or fake one. That is our final model. Okay. So the generative network is trained to maximize the final classification error, and then it's move on to the identify the real one and the fake one. So real world data and also generated data both are combined with this particular place. Here is move on to the discriminatory model. The discriminatory model to minimize the classification error. So the kindly noted this kind of word is a maximize is a minimize. The generator will be create the random based on the random values is create one kind of model generated image is there. So maybe in the particular generated model, the generated data, it is having lots of errors or lots of noise values out there. So when the discriminative model will be there, that discriminative model will be expect only minimize of the errors, because of the real real data is not have a error values, right? So then only it is mentioned like the discriminative network is trained to minimize the final classification error. Finally, it's decided the classification error is the basis metric for the training of both networks. So when it is not properly generated, or else most of the data is having the fake one, means it is again going to the back propagation. Again, it comes to the generative model, generate the new data, again comes to the descriptive model for identification. Finally, it decided it is a real or fake one. This is the way the model, GAN's model will be working like this. Okay, so next we are entering into we can building this simple GAN for MNIST digit generation, hand digit generation. This is our project name. Yeah, exactly. GAN generative discriminator are making by any neural network. No, it is only working with the CNN, convolutional neural network. If the any image related data is only fit for CNN model, CNN architecture. That is convolutional neural network is mostly fit for the image related data. So every data based on the data space, the neural network architecture is differ. So generally the based on the image or video related data, it is fit for the CNN model, or text or numbers related is artificial neural network. It is fit for that, and audio related data, it is okay for this the recurrent neural network. Okay, why we should not take data set as huge data set as text? Like Anju, I cannot understand your question. So if you asking why we cannot take, we should not take data sets as huge data set as a text. Here the text is no needed, right? So our motto is what is the object present in this particular image? The image is real or fake. Okay. Here there is no way to usage of the text. Why are you asking this question? And Meena, you can Meena ma'am, you can asking why generative model tries to maximize the classification error. Because of it is randomly generate the model. Okay, now it is not a real one. Randomly it generates the one kind of sample model for training data. Okay, so for example, if I said to you, okay, so you can create one kind of own model, or else you can create your own kind of own what is that? Yeah, simply I said. So now I said to you, you can create draw the one kind of animal. It is a wild animal. Okay, his eyes looking like this, and also his what is that color is looking like this. Just overall like overall way, I will set to the particular thing. Okay, how you do that exact answer to my expecting thing? I will just orally set to you. You can make this drawing like this format. So you can do that. My exact output, you can give it that. So this same like that here also. A generative model will be generate the data for the own assumption. It is not exactly is happen. So then only the maximum of errors is happen in this particular generative model. Yeah. Okay. Okay. Fine. Yeah. Okay. Me. Okay, ma'am. Thank you. Okay. So here we can entering into the MNIST digit generation using PyTorch with the simple GAN. So GANs for MNIST digit generation involves a training a generated network to produce the images to closely resemble the handwritten digits found in the MNIST dataset. The ultimate goal is to achieve a generator that produces the digit samples indistinguishable from the real MNIST digit, showcasing the capability of GAN in generating realistic and diverse data. So we can repeatedly say the MNIST. What is the MNIST exactly means? It is Modified National Institute of Standards and Technology. this kind of institution will be create this kind of data set, introducing this kind of data set. Okay, so it is a widely used benchmark in the field of machine learning and also computer vision. And if I go with the previous slide on, okay, so it is just introduction. So how the MNIST or with the particular MN data set. So we will share this presentation. Don't worry. So it is consists of a collection of 20 cross 20 pixel grayscale images and handwritten digits starting from the 0 to through to still 9 with a total of 16,000 training images and 10,000 testing images are there. And MNIST serves as a foundational dataset for various image processing tasks and is particularly popular for evaluating the performance of generative models. So first point, the MNIST institution will be create a benchmark of this field of machine learning and computer vision to provide the data sets, and it is consist of collection. The images will be only present into the 20 into 20 cross 28 cross 28 pixel is then fit for this particular GANs models. What you said, Anju, YouTube as there you may see live session along with the previous one. That any errors or any deviations that, or to try to say. Okay, I cannot properly understand your question. So if you have any problem in a YouTube live, okay, not audible though. Now it's audible. Yeah, okay, okay, fine, fine. No, I'm not having any kind of issues like that. Okay, now I continue. Okay, okay, fine. Now I continue. Okay. So the second point is represent to the every images the pixel rate is 28 into 28, and the particular handwritten written digit is having still 0 to 9th numbers, 0 to 9 a range of numbers with a total 16,000 is a training images, 10,000 is a testing images for our model, and it serves to the foundation dataset is a various image processing task and particularly evaluating performance of generative models. And what are the procedure in the particular project? First, we can collect data collection, then data exploration, and creating a generator and discriminator model. And we can set up the parameters of loss and optimizers and creating a training loop. Finally, we can view the result in one of the tensor board, like a dashboard. We know that now. Same like the tensor board is also have to viewing our result and easily understanding to our how much of fake data and how much of real data is there. So what is the max behind the particular GAN? So here is a formula. So kindly just see what is formula. We can frame it that is no need to implement into our model. It is behind the process of our model. So just we know about that. So how it is happened, right? The X is mentioned like a real data. The Z is a latent vector. The G is a fake data, and the D is a discriminated evaluation of real data. DG is an discriminated to evaluation the fake data. The error is happening the A and B. That means real and fake data. I'm not audible now. Now I'm audible. Yeah. Okay. Okay. Fine. Fine. Yeah. Okay. Fine. Fine. Thank you. Okay. Okay. Yeah. Anirban It is not, it's just an example formula, how it is create. It's no need to implement into our manually, we can implement this formula into our model. Okay, just we know this is the formula wise it is happen. So our main thing is in minimum maximum value. Okay, we have to minimize the generative models errors. We have to maximize the discriminated models errors, right? So the V is an discriminated generator. That is our V is in our result, viewing result. The D is an discriminator, G is an generator. Okay. In this particular variable, we have to apply this formula. Okay. Okay, just a minute. Okay. So in our models, every model will be create like the images create like a log files. Okay. So the data will be passing in the every places. So it is a discriminated model will be analyzed. So it is a real or fake. In case it is fixed into the fake one means it's go move on to the backward propagation. Again, it's going to the generated model. Again, it's come to the discriminated model. This is the way it is working like that. Just you know, okay, don't complicate this kind of formula. The two models are trained such that the discriminator strives to distinguish between generated and true examples, while the generator seeks to confuse the discriminated by producing data that are as realistic and compelling as possible. The GAN can be seen as an interplay between two different models, the generated and the discriminated. Therefore, each model will have its own loss function. How that what is that? The generator will be recreate the additional thing means based on the loss value, that generator will be adding the new features in this particular generated image. So I said to now, so once first, okay, if I go with that flow chart. In first time it generate one kind of first model. Okay, first, sorry, in first time we generate the one first model, that is first one. Okay, it is the first image. It is going to the discriminator, it is decided to the fake one. Again it comes to the back propagation. Okay, now so here it's come to the back propagation. Here generated the second one. So second one it is generated. So again the in this particular second option is having some kind of features. So like this kind of way the rupees will be rejected. So this kind of feature is missing in this previous generator model, like generator image. Again, it is added to that. Again, it's move on to the discriminated. This time also it is rejected. Again, it comes to the generator model. Every time it is getting some kind of loss values. In this place, it is getting some kind of loss. Loss value. Based on this loss value, it is fixed to the first time is getting the 0.5 means second time it is getting the 0.8. Because of in the between the three value it is reduced. So before that first time we can get it to 0.5 value, like 5 loss value. Second time we can move on to the additional 3. So again the 3 values will be increased. Okay, so this is the way it is happened. Okay, this also is applied in this place. The loss value is there. Based on our every discrimination process, we can get it one kind of loss value. The loss value will reduce after every back propagation. Yeah, of course. Every time we can add it a feature in this particular image, right? The generated image. So then only the loss value will be decreased. So the generator takes a random vector as input and generates an output image. The discriminator takes either the generated image or a real image as input and generated on output. During the discriminator training, the generate weights and biases are frozen. So based on the loss values wise, the generated image is move on to the real one. The discriminator is penalized when it is predicts a real image or fake image as real. The weights and bias of the discriminator are updated through backpropagation from the discriminator loss. Similarly, during the generator training, the discriminator's weights and biases are frozen. The goal of the generator is to deceive the discriminator. Hence, the generator is penalized if the discriminator can identify the image generated by the generator is a fake or real. In case this loss is backpropagated through the generator network to update its weights and bias. So binary class entropy, it is the loss value formulation. So we have some kind of loss value. So every log file, that means our image file is having some kind of loss. Every time the image will be rejected for the particular fake one, it's again do that the back propagation, right? So every time the binary cross entropy formula will be applied in this particular place. So here the loss will be applied. Again is minus the particular what is that? Loss. So log and p1, the y is in real like the real features. The y is represent to the real features. The p is represent to the fake features. Okay. So there's the same thing one. The one is represent to the real fake one. The zero is represent to the real one. For a real input, y is equal to 1. The substituting this one is the binary cross entropy loss function gives the below loss value. So the 0 is represented to the fake. I think I will reversely set like that means discriminator loss. So just now I said the discriminator loss means every time our image will be decided in the particular discriminator it is a fake one. So by the discriminator will be give us some kind of loss values. So this time in this particular data is having these kind of values will be loss. That means the features values is mentioned like a loss values. See here in this place is having the some features will be missing in our first attempt, right? So again, we can go with the back propagation. Okay, I mentioned it. This one is a back propagation. It is a back propagation. Okay. So again, we can come with the back propagation. And next time we can add some kind of features based on the this kind of real data. So every time the discriminator will be provided to the some loss values. First attempt we can get it the 0.5 loss value. Second attempt we can get it the 0.8 loss value. Second attempt also is what is that? Loss means we can get it the another value that is 0. This time is an I think. Oh, sorry. Next attempt we can get it the one value. I said it to that first time we have missing the 5 kind of features missing in that our generating image in first attempt. Second attempt the 3 will be increased. That means the 2 features will be missing. Third time we can equally similar to the real image. Understand? So 10 out of we can say it like that means if we needed 10 features to matching to our real data. So first attempt we get a 10 out of 5. So second attempt we get the 10 out of 8. Second attempt we can adding some kind of features. The final attempt we can got 10 out of 10. So this is the way I can set like that. This is 0 0.5, 0.8 and 1.0. Yeah, I understand. I understand. I think or I have to understand to you. Then only I said like that this way. So once I go with that particular project, you can easily understand this one. I said like this one, this kind of way I said. Okay, so next one, so combining both the above losses for the discriminator, one for a real input and other one is a fake input. And the discriminator loss, the goal of the discriminator is to minimize the loss values. And the remove with the negative sign will change in the minimum to maximum. Hence, the final discriminator loss for a single data point can be written as. So generator also same like the generator is a loss is calculated for the discriminator loss. During the training of generator, the discriminator is frozen, like it is freeze, it is not working. Hence, only the one input is possible to the discriminator, which is the fake input. The nullifies is the first term in the discriminator loss equation to zero. The zero is a fake one is a real one. So that also is mentioned in the generator model also. So this is the minimax game played between the generator and the discriminator. And the generator tries to minimize the loss, whereas the discriminator tries to maximize the loss. And generalizing this equation to the expected values for multiple data points, give the final equation as below like this. Okay. Okay, so now we are entering into the particular project, our MNIST digit generation, image generation. So go with that Colab. I have to upload this one. Okay, so now it is also same like that previous class. Here also you can connect with that your runtime as a GPU format. It is helpful to make the data it's easily get it that. Okay, so now I can continue with that same like us important libraries we have to import. So pandas is entry processing library. NumPy is handling the null value, like that means numbers. And the matplotlib is having the create the some kind of plottings. And torch vision is like PyTorch is important to the generate the new data so like images and transform the transformers is help to transform the data into these normalize the values and data loader is same like us to import the data into the torch vision and the summary writer is helpful to make the tensor board like on the kind of creating the board as well as give us some kind of summary about our real or fake image. First I have to import this kind of libraries and then I have to go with that next one that is data loading process same like as yesterday session. The data uploading process is common to every generative concept like GAN or VAE models. First of all, I can create the transform and the transformer start compose the values into the tensor value to normalize the value into the 0.5, 0.5 because here also we can using the image, right? So every image values is normalized into the 0.5. Next, we can create the data set like this torch vision data set. Here MNIST. Yesterday we can mention like a fashion image MNIST. Here just the MNIST. It's a basic data set only we can using for GANs, right? And when I can represent to that the root of the URL of data set and transform and download it is true and we can train the data also is true. So once I run this, the every transform the data will be generated like this. When it is done, then we can go with the class of index. It is also having the 0 to still 1. Okay, wait a second. Okay, now I continue with this. So in previous session, we have a class of the name of the labels and also indexed value, right? Here, same like that, the zero, the numbers, like the handwritten numbers are represented to the starting from the 0 to still range of 9. So 0, 1, 2, 3, 4, still 9 is here. Then we have a 32 batch size. In that particular place, we have some kind of object represented with the particular image, right? So that time we can mention to the 128 batch size. Here the 32 is enough for this because of it is the only numbers. It is not an object, or else it is not a shaping related thing. Then only we can represent to the 32 batch size for each epoch. And the data loader is represented to the data set and batch size and shuffle. The randomly it is assigned. Then we can create the sample one. So plt.figure of the particular plotting size, and I am show of this particular image. In one image will be represented to this particular place. Here the loader, the data loader will be passing it here, and the zero values will be represent 0 index to 0th value, and permit to the 1 to 2 still 0. The color map is gray. The color map is to our wish. So if we can add it the color map gray or whatever it is, we can give it like that. So it is mentioned like the one of the handwritten number will be repeated every time I run this. The image, the number will be changed. So the 7 and 3, randomly the numbers will be repeated. That is the permute function to execute the particular numbers in a random wise. Okay, so if I have to change this one, if you have to different color map means, once you can give it the error in this particular place, you can see the multiple types of this particular color map. So the ASNT are blues, and the blues are some lots of color map types is there. So whatever it is, you can choose. If I mention to the ASNT R means it is changed the color based on the image, the number image. You can try to implement this one. If I run this, you can see like this is a AS and R. So R blues is there now, right? So I mentioned like a blues means the image is represented to the blues format. Yeah, it's a capital it, right? So I mentioned to the blue R. The blues are. Now I run this. So the number background will be represented to the 7. So whatever it is, you can give this. And the device, so next one I will represent to the device. Our device is an CPU hardware or CUDA hardware, whatever it is, we can check it like that. So now my device is in CUDA format. It is most helpful to update my data. So next I will implement the torch in the neural network format. First we can create a discriminator for initialize the data. Okay, first I have to initialize the data based on the neural network wise. So the init is a parent function. In this particular parent function is having child function also there. So every data will be passing into the parent function and then allowed to the child function. Okay. Then the self dot discriminator of sequential layer for starting with a linear and ending with a leaky relu and linear. Again, is go on to the sigmoid function. Finally, it's move on to the forward. Forward means additional layer is move on to that. Okay. Yeah, 28. That the layers count is 28 for discriminator. So based on the training data wise, the layers count will be increased or decreased. It is not a fixed one. Okay, so next one we can move on to the generator. Here the generator model will be create the one kind of generating image based on the linear value. The Z dimension, that is the creator one, starting from the 256. Again, it is reduced for the particular thing. Yeah, yeah, we will share it the attendance link. Yeah, wait. Okay, wait a second. Yeah, of course, it depends on the input data, because how much of our data we can represent that. Okay, wait a minute. I will be back. I can go with that. Okay, wait a minute, guys. Okay, I have. Yeah, I was shared the attendance link in the chat box. So kindly fill it your attendance. And okay, now I continue with this. Okay, now I continue. So then the generator will be creative some kind of yeah. So the model will be the generator model will be create some kind of generated image for testing purpose. Then the dimension will be converting into the 64. The image dimension is a 28 cross 28 cross is into 1. Like dimension range of this particular image. Already we know about the pixel range is a 28 into 28, right? So same format will be maintained in this place. So we will mention, and a discriminator is having image dimension to our device, and generator also same like the image mentioned to our device. Okay, I forgot to run this. Again, I fixed to the discriminator generator connecting to my system device, and I may reduce the noise of this particular one. So this every process will be applied in our tensor board. So we can see this particular noise reduction and everything. And the criterion of the price binary Gaussian trophy last value will be represented. So the everything is mentioned like a epochs value of 10. So 10 kind of training epoch will be there for our training purpose. So the writers will be need for everything. So for example, our real or fake, the both images having the some kind of written file is needed. That means image files. They were separately given to the both the fake or real one. Okay, so next the step value starting from the 0. So the epochs will be starting to the looping concept. So epoch in range of epochs starting from the real one and into fake one. The enumerate of this particular data into loading for 0 to still 784 range of the dimensions, and to divide the noise will be reducing the based on the batch size and the epochs count wise the noise will be reduced, and discriminator is having the real one. Okay, yeah, the discriminator is having the real one or decided to the fake one. So first, the discriminated real one, we use the -1. So reduce one minus, like one last value will be reduced. Again, the last value will be mentioned in this particular place. Again, it is mentioned to the fake one. The fake one also is having some kind of loss value. So every time the real or fake image is having some kind of loss values, get it from the discriminated model. When the zero gradient will be applied, the backward propagation will be true. So the optimizer will be applied to the step by step. The output will be comes to the disk of the fake one is then or real one. The loss generator criterion is having torch.ones like is an output and the gen.0 gradient value, and the loss generation is having backward propagation. And if the values, the image is in 0 means that is a fake one or else it is a real one. So based on the epoch count wise, the generated loss and discriminated loss both are mentioned to the in each and every epochs. Okay, so with the torch gradient value to represent the like reshaping the dimension of our image. Okay, so then the image grid fake isn't normalized and the real one also is normalized this one. Finally, we can add it, the image into our tensor board in one by one. The step by step, the every epoch or images will be added. So first, this running with that in first epoch, starting from the 0. So you can mention to this, the last D means discriminated value, that is having 0.76. The generated value is in 0.6. So in every epoch, the last value will be, the discriminated value will be decreased, the generative value will be increased. That is our, that one is needed to us also. Okay. Yeah, wait. Once I done this one, again I go with that code. Yeah, already shared with this reference link. Oops. The feedback link, as usual, we can share it in your WhatsApp group. You can notice that every time the loss value will increase or decrease. Finally, our discriminator value will be decreased or increased. That is our major point. You can note that. Yeah, okay, fine. Once again, I will have to share. So still, after the third epoch, the discriminator loss will be every time it is reduced. So once the epoch will be done, then we can get the proper thing. Okay, in this place, we have getting our log files. So I represent to the log files. Means in this log files is created from the summary writer. The writing summary will be generated in this particular log files based on the real and the fake image wise. You can see this, the log file having the fake one also having different summary, and the real one is also having different summary. We refresh this, that also is having like this. So you can see this. This is our fake one's real. We cannot see this one because of it is computer generated values now. So we cannot see the summary. We cannot read this one also. It is a fake ones one, and we also see with the real ones. Okay, once the every epochs will be done, finally we can see with that output in the tensor board way. So this is the syntax for upload our tensor board, like the modulus of load extracting the tensor board, then the tensor board of log directory of our log files. Based on the log file wise, we can show it our output. Once the epoch will be done, so the final last value is in 0.5, the generated value is 1.5. So here the tensor board will be created. You can see, so this is our tensor board. Here, our fake one is mentioned like a gray color, real one is in a blue color. So we can see this. So MNIST fake image is having every 8 kind of steps is there. We can go with every step, we can see the particular thing. So we can step 1, it is some kind of noise will be reduced. Step 2, the darkness of noise will be reduced. Step 3, the object will be comes to the one kind of clearness. Step 4, the what is that? Some kind of digits only it's showing. In every step will be increased. There some kind of numbers will be shown. Like this a 2 and a 1 and this a 3. In every step we will move on to that. We can see some kind of numbers. And the real images is having we cannot get. Okay. We have some problem. Okay, some kind of values will be missing, I think. And only the real one is not showing properly. If you have to see, you can see this clear visualize about this one means in this particular log file also will add it into our major file location. Okay, here I have this one now. So you can see the log files is having today is the 9th date. So here the log file will be generated, right? So this log file, we can extract this zip file into view the particular values in a clear format. Okay, now I show you how can I do that. Okay, I can create a new notebook. Okay, wait a second. I think, yeah, so it is additional thing. The additional format is there. Okay, before that, I have to upload this particular zip file. T4, we can need it to that. Okay, once I connect this, okay, so I try to connect this one. Yeah, so now it's uploaded. Here, the particular zip file I have to upload in this particular data field. So now the log file, the log zip file will be uploaded. Yeah, it is uploaded. Here I have to create some kind of extraction of this zip file. So from zip file and import, zip file. And I have to create with this zip file, of, I have to paste it into our zip file URL. So copy the path and paste it here into the quotation. And I have to read this file. So R is reading the file as zip. ZP is in zip. And mention to the zip dot extract everything, like extract all files into the logs. So it is a zip file URL. We have to create a URL like this, only unzip file. Okay, I run this. If the files are zip, like unzip, you can see this here. The log file is there. The one is a fake and a real. So now I have to create the tensor, like the tensor board to see the clear visualization. Like load underscore axt, like extract the tensor board. And here also passing to the modulus of tensor board and log directory of our log files. If I run this, you can see the tensor board, and also you can see the every digits like a clear format. Okay, so kindly wait, it takes some time to visualize. Yeah. Okay, so now we can see this. It's running. Yeah. Here you can see it is most clearly view the particular images. So based on this step by step, how this kind of clearness is happen means in this time we have to extract the file, and also the 200 count of epochs is running it in this time. Then only the clearness is happened. Every time you have increased your epoch size, like epoch count, we can get the clear view of your output. Okay. So here also we can go with that step by step. Here there is a very noisy digit is happening in the fake images. We can go within step by step. Every steps we can move out with that. The image will be like the digits will be clearly viewed. Is a 2 and a 5, I think 8, 7, 3 and a 4, 1, again 3, 6. These are all the fake images. We have to see the real image also. Here we can see it is a 4 and 0. This also we can reducing these steps and go within step by step. In every steps, the numbers will be replaced. Randomly, the numbers will be assigned. Because these are the it's a real images. It does not have a noise. Every steps we can move on to the numbers will be changed. The 4, 0. We clearly view this number. So we can adjust the size, image size, like brightness, or you can fix the full brightness or contrast. So whatever it is, we can adjust. Then only we can represent the one in a tensor board way. So alphabetical way or else pixel wise, we can ascending or descending, otherwise we can change it this one. Nearest pixel or nearest to y. So whatever it is. So whatever it is we need, we can fix this one. And the card width we can adjust. That means the image view. It is adjusting based on this. The size will be increased or decreased. Okay, so this is the way we can create the generative model and discriminate the model. Finally, we can find out how many fake image digits and how many real image digits happen. Okay, now. So this is the way we can understand. Okay, if you have to go through the code, okay. So which part you need? I need pen butter search. In first, okay, once again you have to go through. First, we have to import the libraries. Okay, so these are the major libraries to import that, and then we have to load the data. So compose the transforms the data like each and every data image size into the normalized to 0.5 size, and then we can load the data, that is MNIST data set, load it in the format, the transform and the download to data and train the data also. Then we can find out the class of index in our data's digit numbers, and the batch size, how much batch size needed, that is 32 batch size needed. We can fix the size of the particular like count of the batch size, and we can load the data into our data loader. Finally, we can extract the one kind of handwritten image in this place, that is 7. So I have to reconnect this one, and I have to checking the hardware unit of our thing, the CPU or CUDA, whatever it is, we can check. Then we can create the discriminator model. Okay, so discriminator model is needed to create because of already having the like training to our discriminator. Then only it is find out our data is real or fake. So here I have to train the discriminator model. Then I have create the generator model to generate the new data. So based on the neural network wise, we can figure the size and the neuron count, everything, image dimension, everything we can create. Once it's created, is move on to the forward propagation. That means move on to the next step. Here we can mention to the discriminator generated. Both are combined with to my device, that is CUDA device. Then is have to fix it to the noise. So based on the noise wise, every time the batch size will be completed, the noise will be reduced. That is this kind of thing. And next we can mention to the cross entropy value, loss value. Discriminator and generated both are having some loss values. That is mentioned like a 3e minus 4. That is the one of the unit of learning rate. LR is mentioned like a learning rate. The every loss is the particular data will be getting to the one kind of learning values. So total number of epochs is having 10. So I mentioned to the 10 epochs. And I mentioned the summary writer of log files like Individually, I have to create log files for fake and a real. Everything is having the step format, like zero, starting with zero. And then I have to create in the individually training the discriminator and training the generator. This kind of passage is having the train the discriminator, and then next one is the training the generator one. Then I have to mention the number of epochs based on the last value of discriminator and last value of generator. The epochs means it is mentioned to the count of the training size. I think it is size. The one epoch means first time it is trained. The second epoch means second time additional data, like another image going to train. Image wise, the round of the training count. What training size of? Yeah, that is 60,000 images. Yeah, I try to simple way. Each epoch is having the 38 kind of count of neurons. Yeah. Okay. Each epoch is having 32 batch. In that particular 32 batch is having the some kind of 724 neurons, I think. Here we can see now 724, sorry, 256. In each epoch is having the 32 batch. Okay, so 32 batch is having the each epoch. In that particular 32 batch, in single batch is having the 256 neurons. So you can calculate that in each batch size having the 256. 32 batch size having multiply with the 32, can get it the neurons like that way. So based on the epoch count wise, we can get it in every time. We can get it the loss or loss discriminator and loss generator values is we can get. So based on the every loss value, the generated model will be comes to the proper real image wise. Here we can fix it to the gradient value of this one, and we can mention the normalize of the every real or fake data. Finally, we can mention the grid value, like grid shape of the real and fake. Finally, the every epoch is move on to the single step. So first epoch will be completed, it's move on to the next step. Finally, we can represent the fake or real image into the tensor board way. In this tensor board is represented the every values. Yeah, of course. So our formula is same like that now. So yeah, we have to increase the generator loss, but decrease the like maximize the generator values, minimize the discriminator values. That is our major thing. In slide, okay, slide. That is the slide is here. Yeah, here you can see the generator model. We have to maximize the error. That means maximize the loss value. The discriminator is having to minimize the loss value. Then only we can get it the our generator value is comes to the real or fake. Okay, so that's it. So this is the way we can see the output for this one. So it is a basic GAN using MNIST handwritten digit image. So definitely we have tried to share this kind of source code and presentation in tomorrow. You can work with yourself. If you have getting any errors or any queries, you can ask into in the particular group, or else you can asking in a next class. We will discuss about that. Okay, so that's it. So today the session was done. Still you have any doubts, you can ask, or else we can leave. Yeah, okay, fine. Thank you. Thank you, Srinivas Kumar, Kanagavali, ma'am. Thank you. Sunita Vela, thank you. Attendance already we shared, ma'am. So okay, once again I reshare the okay, reshare the attendance. So kindly fill it your attendance. Don't forget. Okay, thank you everyone. Thank you. Yeah, okay, thank you everyone. Yeah, of course, Vaishnavi ma'am. Yeah, okay. Don't forget to give it your attendance.